In this section we talk about the definite integral. In the previous sections we dealt with the integral of f of x dx. So in this case we integrate over the domain of the function for all values of x that are allowed, I mean belong to the domain. But here in this section we'll focus on finding the integral over some specific interval, I mean from a to b. We find the integral from a to b, from a specific point to another specific point. So here the definite integral can be represented as the area under f of x. So this can be thought of the area under the curve of f of x, the function f of x, from x equals a to x equals b. So we may have an area like this if the function f of x, the graph of the function looks like this. This is f of x, y equals f of x, and we integrate, we find the integral from a to b. So we want to find the area under this curve, this shaded area. This area is represented, can be represented as the integral. This is the area. Area is the integral from a to b, of the function f of x dx. This will give you the area under this curve. Why integration is so important? Because in most of the cases we don't have regular shapes. For example, if we have a rectangle, this length is 2 and this the width is 3 or 1, then if I ask you to find the area of this, you say that area is length times width, so it's 2 times 1. 2 times 1 is 2, and that's it, because this is a regular shape. If I give you a circle of some specific radius, you say that the area of this circle is pi r squared, and that's pi times 2 squared, it's 4 pi, and that's it. But this shape is, as you can see, the area under this function is not a regular shape. So how to find this type, these areas? To find these areas we can use integrals. Okay. Now we have two cases. If the function f of x is greater than or equal to 0, that means the function is non-negative. For example, the area is this. Here the function is above the x-axis, so it's non-negative. So to find this area, we just find the integral from a to b f of x dx. So area is represented as a function, as an integral. Now if we, for any f of x, for any function, say the graph looks like this. Now here, if we want to find the area under the curve, as you can see, we have this area, and this area. So we have two areas, area 1 and area 2. If the area is above the x, area is always positive. But when we find the integral, for example, from a to b, the integral from a to b f of x dx is the area above the x-axis, which is positive because it's above the x-axis, plus the area below the x-axis, but this is negative. I mean, we multiply it by negative sign because it's below the x-axis. So we multiply area of 2 by negative to get the integral. So it's the area above the x-axis minus area below the x-axis. That should give us the total, should give us the integral from a to b. Now, in order to find area of this shape, for example, if this line is y equals x, and we want to find this area. As you can see, this is regular area, so area of a rectangle. So the integral from 0 to 2 of the function x dx equals the area under this line, which is 1/2 of the base of the rectangle of the triangle is 2, times the height of the triangle. The height is 2, because if you plug x equals 2 here, you get the value of y equals 2. So 1/2 times the base times the height, it's 2. Also, if we have an area like this, same function, let's use y equals x, and here this is +1, this is -1. We have two areas between the function y equals x and the x-axis. So in order to find the integral from -1 to 1 of x dx, we have the area above minus area below. So area above this area, let's call this A1 and this is A2. So A1 minus A2. So area A1, 1/2 of the base is 1, times the height is 1, minus area of area 2 is 1/2 times the base of this rectangle. The base is 1 unit, it's +1, times the height. The height is 1. We are talking about lengths, that's why we just consider positive cases. So this is 1/2 minus 1/2, which is equal to 0. So this is the integral from -1 to 1. Now we have a very important theorem. That theorem is called the fundamental theorem of calculus. So this theorem says that the fundamental theorem of calculus, it consists of two parts, but we will just focus on one part in this section. So if the function f of x is continuous and defined on the closed interval AB, and let f be any antiderivative of the function f on the same interval AB, then the integral from a to b f of x dx. Now instead of finding areas as we've seen in examples 1 and 2, and that's not possible when we have a shape like this one, because this is not regular shape. So how to find the area under the curve? That means we need to develop a technique, mathematical technique. That technique is called integration. So the integral from a to b of f of x dx is capital F of b minus capital F of a. What does that mean? That means we just find the antiderivative of the function f of x, one of the antiderivatives, and then we plug the upper limit of the integral and the lower limit of the integral and find the difference, the upper limit minus the lower limit, the substitution of the upper limit minus the substitution of the lower limit. So the fundamental theorem of calculus, this part of it, represents a way to find the integrals. Let's take an example. If we have the integral from 0 to 1 minus x squared dx. Now instead of graphing this function and trying to find the area under that function, we can find the antiderivative of this function. What is antiderivative of this? Antiderivative of this is the integral, as we learned in from a previous section. So what is the integral of 1? It's x. What is the integral of x squared? It's x cubed over 3. We add 1 to the power and divide by the new power. And then we evaluate this at 1 and 0, and then we subtract them. This is capital F of x, and this is A, this is B. So we find f of 1 minus f of 0. So substitute 1 here. So we get 1 minus 1/3 minus substitute 0, 0 minus 0 cubed over 3, and this is 0. We have 1 minus 1/3, it's 2/3. Another example. If we want to find the integral from 1 to 5, 1 over x squared plus 1 over x dx, well, what we need to do is to find the antiderivatives. But this is x squared, we can bring it up here. The integral becomes integral from 1 to 5, x to negative 2 plus 1 over x dx. Now, what is integral of x to negative 2? The integral of x to negative 2 is x to negative 2 plus 1 over negative 2 plus 1. Plus, what is integral of 1 over x? The numerator is the derivative of the denominator, so it's natural log of absolute value of x. Now here we don't add c because we have limits of the integral. So for definite integral, this is called definite integral because the domain on which we integrate is specified from a to b. So we need to evaluate this at a and at b, but a equals 1 and b equals 5. Now this is x to negative 1 over negative 1 plus natural log of absolute value of x from 1 to 5. Now this can be rewritten as, now we have negative 1, so this is just a sign. X to negative 1, if we bring it down, it becomes x to the power 1 plus natural log. Now we don't need absolute value of x because x is from 1 to 5. It's always positive, so we don't need the absolute value. So it's 1 to 5. Now we substitute the upper. This is f of x, capital F of x. So we substitute the upper limit minus substitution of the lower limit of the integral. Now let's substitute 5. We get negative 1/5 plus natural log of 5 minus substitute 1, negative 1 over 1 plus natural log of 1. But natural log of 1 is 0, so we get negative 1/5 plus natural log 5 minus 1, minus is a plus 1. And then we can add these two. Negative 1/5 plus 1 is 4/5 plus natural log of 5. This is a final answer. We don't have c added to this because this is definite integral. For indefinite integral, we add c, the constant of integration. Now let's take another example. If we want to find the integral from 0 to 1 x over 1 plus x squared dx. Now how to find this? We can't find this integral directly, so we need to think of some methods. We learned one method in the previous section. The method is the substitution method. So look at the original function or the main function. The main function is 1 plus x squared because its derivative or part of its derivative is the numerator x. The derivative of the denominator is 2x, but we have x part of it in the numerator, so that means we can apply substitution method. But here we need to pay attention to something. The function is bounded, so we need to add one step. So let's start with the substitution. Substitution u equals 1 plus x squared. Then we differentiate this, and then we solve for dx. dx is du over 2x. Now after this, we need to change the limits of the integral because these are values of x. These are values of x. So we need to write them as values of u. So when x equals 0, what happens to u? u is 1 plus 0 squared, and that's equal to 1. When x equals 1, then u equals 1 plus 1 squared, and that's 2. Now we changed the limits of the integral. Now we plug into the integral. So x equals 0 corresponds to u equals 1. X equals 1 corresponds to u equals 2. Now we have x over the denominator is u because u is 1 plus x squared. dx is du over 2x. And then we cancel the x's, and we get 1/2 integral 1 to 2 1 over u du. But the integral of 1 over u is natural log absolute value of u, and we have 1/2 here, and we integrate from 1, we evaluate this on the interval 1 to 2. So we substitute 2 here. We have 1/2 natural log of 2 minus substitute 1 natural log of 1. Natural log of 1 is 0, so we have 1/2 natural log of 2. That's the final answer. One more example. If we have the integral from -5 to 5 of e to 1 minus x dx, we can use the shortcut that we learned before in the previous section. This is ax plus b. So a is the coefficient of x, it's -1. So 1 over a, the integral is 1 over a times same e to the ax plus b. So 1 over -1 e to 1 minus x from -5 to 5, and that's e to -4 minus e to 6. So that's it, e to the 6 minus e to -4. Or if you want to use substitution method, you don't want to use the shortcut, you can do it by using substitution method. U equals 1 minus x, and then du equals -dx, and then when x equals 5, then u equals 1 minus 5, which is -4. When x equals -5, u equals 1 minus -5, which is 6, and then the integral becomes -4, integral from -4 to 6, e to the u times dx is negative du here. Dx is negative du. We multiply both sides by negative sign, negative du. So negative sign can be brought here. It becomes negative, the integral from -4 to 6 e to u du. And then what is the integral of eu? It's just eu from -4 to 6. Now we substitute the limits, negative e to the 6 minus negative e to -4. Negative is plus, so we get e to the power 6. I think I reversed the order. Let me double check here. U is 1 minus x, du is -x dx. This is correct. So dx is negative du. Now when x equals 5, u is 1 minus 5, which is -4. When x equals -5, then we have 6. So the lower limit is, I just reversed the order. So the -5 x, which is the lower limit, correspond to 6. So this is 6, this is -4. So I should change these. So we have 6 -4, 6 -4. Now this becomes e to -4, substituting -4, minus e to the 6. Negative is positive, so this can be written as e to the 6 minus e to -4. And as you can see, we got same answer. So it's up to you to use the shortcut or the substitution method. Let's do another problem. The integral from 1 to 2 square root natural log of x over x dx. And actually here we are reviewing substitution method. So here we have natural log, so u equals natural log x, then du is 1 over x dx. So dx is x times du. Now when x equals 1, u equals natural log of 1, but natural log of 1 is 0. When x equals 2, then u is natural log of 2. So the integral becomes integral from 0 to natural log of 2 square root of ln x. Ln x is u over x. Now what is dx? Dx is x du, and then we eliminate all x's and we get the integral from 0 to natural log 2 u to 1/2, because square root u can be written as u to 1/2 du. And this is, now we integrate this by adding 1 to the power and dividing by that new power. Integrate from 0 to, or substitute 0 and ln 2. So this is u to 3/2 over 3/2. From 0 to ln 2, we can flip the denominator because it's a fraction. It becomes 2/3 u to 3/2 from 0 to natural log 2. Now substitute this natural log 2, you get 2/3 natural log 2 to the power 3/2 minus, substitute 0, you get 2/3 0 to the power 3/2, but this is 0, so the answer is 3/2 natural log of 2 to the power 3/2. Now, as you can see from these examples, all these examples, for definite integral, the answer is always a number. This is a number. This is a number. We don't see it. We don't see any x here. This is a number. So answers are numbers for definite integral, as you can see. But for indefinite integral, we get some values of x in most of the cases. So that means we obtain a function. Now the last example here is an application of this type of integration, or indefinite integral. So if we have a catastrophic, if a catastrophic accident of an oil tanker caused an oil leaking in the ocean at a rate of 0.08 t squared minus 4t plus 60,000 barrels per day. So this is the volume of this oil leaking, and t here is between 0 and 20, where t is time in days, since the first day of the leaking. The question is, compute the total volume of oil released during the first 20 days. So we want to find, we have the total volume. The total volume here, we are given the volume here of the leaking over time. So we have total volume is the integral from 0 to 20 of the volume function. And then we find this integral from 0 to 20, 0.08 t squared minus 4t plus 60 dt. Then we integrate. We have 0.0, we need to integrate this, 0.8 t cubed over 3 minus 4t squared over 2 plus 60t. This is the integral of the integrand from 0 to 20, and then plugging 20.0820 cubed over 3 minus 4 over 2 is 2. So 2 times 20 squared plus 60 times 2. This is the substitution of the upper limit minus substitution of the lower limit, since we have t's here, so it's 0. Now using calculator we get some number like 613.3 thousand parallels, and that's it.